Hello friends, so today we can discuss this question from LeetCoding Challenge Problem 6 Majority Elements. If you like these videos, please hit the like button and subscribe to my channel. So the question statement states that you are given an array of size n. Find the majority element. The majority element is the element that appears more than n by 2 times. So it should appear more, not equal to it. Okay. So you may assume that the array is non-empty and the majority element always exists in the array. Okay, cool. So let's look at the inputs. For this input, because 3 appears 2 times and 1 appear 1 times, and the size of the array is 3, so 2 appears more than n by 2 times, which is like 1. So answer is 3. For this case, 2 appears 4 times and 1 appears 3 times. So as you can see, the answer is 2. So there are basically a number of ways to solve these questions, but the two most important, more important ways can be using a hash map or using an algorithm called Bore-More voting algorithm. Okay, so we'll discuss both of them. The first way is you can just make a hash map or a map in C++, store the frequency of every element, and then iterate over the hash map and see which element has occurred more than n by 2 times. If we have reached that element, just return that answer. If not, because they have told that the majority element always exists, so we'll just have to return the number. So we'll directly run on the code, and if you still have any doubts, please mention down. The code is very simple. So we'll make a map, store the size, and then what we'll do is in the map of nums of I plus plus. So this is used to store all the frequencies, and then we'll iterate over the map, use the auto keyword. So the map first value stores the actual value of the element, and the second value stores the frequency. So now what we have to do is that if I dot second, which stores the frequency, if the frequency is more than n by 2 for any element, what we have to do is we return I dot first, which is the value of that character, like the element. Else we can return -1 just in case, but we don't require that. But because it's a returning function, we should write it. Okay. So as you can see, it's accepted. The code is very simple. Now we'll move on to the Bore-More voting algorithm. So I write the name of it here. Bore-More voting algorithm. Okay. So this is the name of that voting algorithm, and let's see what it assumes and how we find out the answer. Okay. So the voting algorithm states that if that element exists, which is majority element, if we know that majority element and if we cancel out with every non-majority element, the majority element always wins. It means like in this array we can see, like just assume, or we know that the answer is 1, but like if we don't know, even let's assume that this is the majority element. So, and rest of them are not the majority element, obviously. So we'll cancel out the majority elements with the non-majority elements. As you can see, if we cancel out this, we cancel out this, then the only element which remains is the majority element. Why? Because it's more than n by 2 times. Okay. So as if that, like, take an example also. So if we have this again, so if we like just cancel out any of the numbers which are the majority with the non-majority, the majority elements always wins because they are more than n by 2 times. So what we'll do actually is we'll start from the start and just assume we'll have this array. We'll take a simple example first. So this is an array and we want to find out the majority element. Okay, so at the first we'll assume this to be a majority element and initialize our count, like just assume our count to be 1 because we have seen this to a majority element and its count is 1 because we have seen one element. Now we'll move to the next element and see whether this is also our majority element, which means whether this is also equal to 1. No. So it means we have to cancel it out. So we'll make our count equal to 0 because we cancel out this with this. Okay. But at this point, when our count becomes 0, it means till this point, this subarray has no meaning to us, because till this subarray, everything cancel out. And we just have to find out the majority element in this subarray, because this subarray nullifies everything out. Okay, so now we assume this to be our majority element. Just assume. And we'll make our count equal to 1, because we have found one of our majority elements. Now, because this is not also equal to a majority element, we'll make our count equal to 0 when we are on this point. And now again, till this subarray, everything nullifies. We don't have a majority element till this point. Now we'll make this a majority element, and we make our count equal to 1. And now we don't have any element more left. So now this is our majority element, which is this one. I hope you understand. So let's take one more example. You have, let's initialize it with 2, 2, 1, 1, 2, 1, 2, 1. So we'll take this to be a majority element, and like just take this again 2, and this is 1, and this to be again 1. So we'll start with this 2. We'll make our count equal to 1. We'll take this 2 again, and we'll make a count equal to 2. We'll take this 1, we'll make a count equal to 1, because these are not the same as the majority elements. We have assumed a majority element to be 2 at the start. So this is not equal to the majority element, we'll make it 1. Now 1 is not equal to 2, so this is not a majority element, we'll make it 0. And it means till now everything nullifies. So now we assume this to be a majority element, which is 1, and we make a count equal to 1. Now we also again hit 2, and we make this again 0, which means till now again we are not finding any majority element till now. We'll make this equal to a majority element, and just we have hit our final answer. I hope you understand the logic. It will be more clear with the code now. So we'll move directly to the code, and what we'll do is we'll assume our candidate for the majority element to be the first element. Because it's non-empty, we can take it to be the 0th element, and we'll make our value which stores the count. Actually, the count stores in the value, and what we'll do is we'll also store the size of nums. Okay, now what we'll do is we'll iterate over the nums array, and if our nums of I is equal to the candidate which is our first element, or the element which we are assuming to be our majority element, if they are equal, then we'll increase our value, which I've told you. If not, we'll decrease our value. But what we'll check is if value is equal to -1, which means, as you can see, till this point, till we hit 0, everything nullifies, but we'll not change our majority element at this point. We'll move to this point again, and at this point also our majority element is not same. So we are at this point, it's 1, it's 2, it's 1, it's 0, and at this point it will become -1. But we have crossed element, which means we have to make a subarray which till 0, which means it nullifies all. But when we hit a -1, it means we have also take one more element. So now we assume this point to be our majority element when we hit a -1, and we make the count equal to 1, which I've told you. So when we hit a -1, we know that before it we have found a subarray which nullifies it. So at this point we take our element to be 1 and take this to be a majority element. So when we hit a -1, what we'll do is we'll make the candidate at nums of I the majority element, and make our value equal to 1. And when we come out of this loop, we'll have to return our candidate. Okay, let's run this first and see. Yeah, it's giving the correct answer. Let's submit this. So it's accepted also. I hope you understand both the concepts and both the codes. If you still have any doubts, please mention down. Thank you for watching this video. If you like this video and you like my explanations, please hit the like button and spread this video with your friends. I'll see you in the next one. Bye.